Hello everyone, my name is Rohit Das. Welcome to my channel. And today we are going to see how we can apply a linear regression on a dataset in Python. So by the end of this video, you would have actually applied a regression model, a machine learning model on a dataset. So let's get started. Over here, I have a simple dataset which has three columns: the employee ID, the years of experience, and the salary per month. Using this, we are going to predict how much salary should a new employee get based on the years of experience. So over here, your salary per month is your dependent variable, which clearly depends on your years of experience, while your years of experience is independent variable as it does not depend on the either two, and your employee ID is something we are not going to take into consideration because it is not going to help us improve our machine learning model. So first thing, I'm going to do this in Jupyter Notebook. You can use Google's Collaboratory or some other platform. Now first I'll create a new notebook and I'll just name it linear regression. The first thing we're going to need is to import certain Python libraries like NumPy, Matplotlib to visualize our data at the end of this video, and pandas to import our dataset in a Python program. So from the pandas, we need the read CSV, and inside this, we'll give the name of our file, that is data.csv. And now we need to divide it into x and y. So our x variable is a independent variable, which was the years of experience, while our y, which is a dependent variable, was our salary per month. So in Python, your indexing starts from 0. So this is your 0th column, this is your first column, and this is your second column. Or you could use a negative indexing where this is your minus 1th column, this is your minus 2 column, and this is your minus 3rd column. So now I'm going to use dataset.ilog. First, we're going to need all the rows. So a colon for that. And we're only going to need the first column up to the last column, excluding the last column, which is the minus 1th column. So over here, this will take the first column up to the last column, excluding the last column, dot values. And again, dataset.ilog. We need all the rows, but we only want the last column. So for that, minus 1, which signifies our last column. Let's print our x and y. So here we go. I'll just run these code cells. And here you see all your data of your years of experience column and your data of your salary column. So you could see over here, starting with 1.5, 1.5, 55,000, 55,000. So now we are going to split this data set into training set and test set. So to do that, we are going to use scikit-learn, sklearn. From there, we are going to need model selection, import, train, test, split. So this is actually part of a data pre-processing. To know more about data pre-processing, you could check out the link in the description down below where I have made a full video covering almost everything regarding data pre-processing. Now we need xtrain to store our training set values of our x variable, xtest to store our test set values of x variable, then ytrain, training set value of y variable, and ytest, training set value, test set value of y variable. We'll call on the class of train test split. It will take x and y variable as its parameters along with test size. So I want my test size to be 20%, that is 20% of all the values present, of all the values in the data set, and I'll take it as random state equals to 1. to make sure that my test set consists of any random values from the dataset and not just the last 6. Since we have specified the test set as 20%, it will only the test set will have only 6 values. So I want any 6 values and not just the last 6. For that, the random state equals to 1. Now over here I'll just print the x train, the y train, the x test, and your y test. So here I go and run all these code cells. And as I said, so this is your these data, this x train and your y train data are your random 24 data from your entire data set. And these are your 6 test set values. So we are going to use a training set to train your machine learning model and test set to check how efficient it is. So once again from scikit-learn, but this time we are going to need linear model. From linear model, we'll import linear regression class. We'll create an object of the linear regression class called the regressor. Linear regression. Linear regression class is not going to take any parameters, and I'm going to simply fit the linear regressor object using the fit method with xtrain and ytrain. So your linear regression model will now be ready according to your training set values. Now you can predict what your values could be. So let's try that. So for that we're going to use regressor.predict. We're going to use a predict method. Let's predict our x test values. So according to our machine learning model, what should be the value salary of a person with 6.4 years of experience, 3.4 years of experience, 8.4 years of experience, these values. So print, then print ypred, which is our y prediction. And here it is. So according to our linear regression model, the person with an experience of 6.4 years should get a salary of 94,826, which is very close to the actual value of 95,250. Similarly over here, there's a 71,569 and the actual value is 76,350. That is a little bit far, but as we can see for the rest of the values, it again is quite close. Now you do not need to compare it manually, but we could visualize the data and we will visualize the data. So plt.scatter. So we want to visualize the training set first. So yxtrain and ytrain. Color equals to red. So this is going to plot your training set values. Then plt.plot xtrain regressor dot predict xtrain. Xtrain color equals to blue. So this is going to give you the regression line which is helping us to predict the values. And let's give our graph a bit of title. So I'll name it years of experience versus salary per month. We'll also give our x and y axis a label. So the x label will be years of experience and our y label will be salary per month. Now let's see plt.show and let's run this. And you can see, so these red points are your actual dataset values. So you could say These red points are basically these values, like for 1.5, 55,000. Well, it's not 1.5. In our training set, the first value was 9.8. So 9.8 will be somewhere around here. So I think this is the 9.8 one. So the person with 9.8 with 106,980 and so on. So this is your training set visualized. So these red points are your actual data, while this is your blue line, which is your best fitted line according to your training set. Let's visualize our test set as well. So we do not need to make much changes to visualize our test set. We can just copy this code, paste it, and over here we just write X test and Y test. Let's run this, and this is your test set model. So this is your regression line. It is the same as this one. And these points are your actual values. And you could say how much, and this blue line is how much this machine learning model has predicted for these values. So you can see for this point over here, the blue line predicts the salary should be a little bit higher, while for this one, it predicts it should be a little bit lower. Now this red point over here, it's exactly on our regression line. So you could say your regression line is working quite well for this data set. So this is how you can implement a linear regression model. It will work for both simple and multiple linear regression. One we have done over here is simple linear regression. But if you have multiple independent variables, it will still work and it will predict a multiple linear regression value accordingly. So thank you. Hope you enjoyed this and happy machine learning.